Today's lesson is on rational root theorem. Basically, this is a way to figure out possible solutions to polynomials. So if we've got a completely factored polynomial, how would we find the solutions? We're going to set each factor equal to 0 and solve for x. So we've got x minus 3, we're going to set equal to 0, 2x plus 1, set equal to 0, and x plus 8, set equal to 0. I'm going to solve. So x minus 3 equals 0. I'm going to solve x equals 3. 2x plus 1, this becomes x equals negative 1/2. And x plus 8 becomes x equals negative 8. So when we find all the zeros, sometimes they'll go ahead and give them to you in factored form. So you're just going to set them equal to 0. So x plus 2 equals 0. X minus 5 equals 0. X minus 3 equals 0. X plus 4 equals 0. And 2x minus 5 equals 0. So when I solve for x, I get x equals negative 2, 5, 3, negative 4, and 5 over 2, 5 halves, 2.5, however you would like to write it. But sometimes they're not going to give it to you factored already, so you are going to have to factor it yourself. So for B, this is a difference of squares. So I'm going to set it up with a plus and a minus. They're going to be the same factors. My first term will be the square root of my first term in my polynomial. So square root of 4x squared is 2x. My second term will be the square root of the second term in my polynomial, which is the square root of 9, which is 3. And then I'm going to set each of these equal to 0. So 2x plus 3 equals 0, and 2x minus 3 equals 0. So I'm going to get x equals negative 3 halves, x equals positive 3 halves, or you could write x equals plus or minus 3 halves. For C, remember we always want to start off and see if there's a greatest common factor. All of these terms divide by 3. So that's the first thing I'm going to do is I'm going to go ahead and take the greatest common factor out. So I'm going to divide by 3. That leaves me with 5x to the third plus 5x squared minus x minus 1. Now I've got 4 terms, so the type of factoring I'm going to do is going to be grouping. So with grouping, I'm going to keep that 3 out front. Remember, I'm going to take the greatest common factor of this first term. I'm going to take it out of those 2 terms. So I'm going to take 5x squared, and that leaves me with x plus 1. I'm going to do the same thing for the second half. So I'm going to take a negative 1 because I want x plus 1 as my common factor. So then whatever I took out as the greatest common factors, I'm going to combine those as one factor. So I've got 3 on the outside. I'm going to make this 5x squared minus 1, and then x plus 1. So I'm going to set all of these equal to 0. Well, 3 does not equal 0. It doesn't have a variable anyways, so we can just leave that out. 5x squared minus 1 equals 0. So I'm going to get that x squared equals 1/5. and then I'm going to take the square root. So I get x equals plus or minus the square root of 1/5. I guess I can zoom in a little bit. And don't forget the plus or minus. And then the last one, the last factor, x plus 1 equals 0. I'm going to get x equals -1. For D, we're going to use bottoms up to factor. A times C on the top plus B on the bottom. 2 times 5 gives me 10. B is 7. My factors of 10 are 1 and 10 or 2 and 5. The ones that add up to 7 are 2 and 5, so I'm going to use those. But I do need to divide back by my A term. So if it simplifies, I'm going to go ahead and simplify. If it doesn't, I'm going to leave it as is. So this is x plus 1 and x plus 5/2. Now normally here we would go ahead and rewrite this second factor as 2x plus 5. However, when we set these equal to 0, you're just going to end up solving it back anyways. So since I've already got 1x, I'm just going to leave that. So I'm going to do x plus 1 equals 0 and x plus 5/2 equals 0, so that I can then solve x is -1 and x is -5/2. You would get the same answer if you made this 2x plus 5. You'd get the same answer. It's just more steps to convert it to that and then solve again. It's like 4 more steps that you don't necessarily need to do. So these would be my x values. So there is something called the fundamental theorem of algebra. This is a whole bunch of words, but I'm going to break it down for you to what you need to know. So the degree equals number of solutions. That's all you need to know. Degree equals number of solutions. And then here is the bulk of what we're doing today, the rational root theorem. We also call this RRT for short. So it says given a polynomial with integer coefficients. And remember, integer just means whole numbers. They can be positive or negative. It doesn't matter. They can be written as P divided by Q, or the way that I usually do this is I do C over LC. And you'll see why in a second. P is a factor of the constant term, which is why I use C. Q is a factor of the leading coefficient, which is why I use LC. And remember, leading coefficient is in front of the highest degree term. Not just the first one, because it may not be written in standard form. All right, so we're going to go to the next page. There's going to be a whole bunch of words. Once again, I'm shortening it down for you. All you need to know is that the rational root test does not give you zeros. What it does is it gives you possible zeros. So it's really just narrowing down the possible answers for us. What it also does, or what we also need to know, is that most of the possible answers will not be an answer, be a zero. And the way that we can figure this out is we can check by using synthetic division. So when we're writing out the possibles, you can use P and Q. You can use C and LC. I'm going to use C and LC because, again, it helps me remember my constant over my leading coefficient. That way I'm not trying to remember which one's P and which one's Q. So that's just the way that I do it. So for this first one, my constant is 7. So I am looking for factors of 7. 7's a prime number, so my only factors are 1 and 7. Or possibly -1 and -7. My leading coefficient is 4. So I'm looking for factors of 4. Those are 1, 2, and 4. So for my possible zeros, remember this is going to be C over LC. So I always start off with my first constant term and divide it by each of my leading coefficient terms. So I'm going to start off with plus or minus 1 over 1, plus or minus 1 over 2, plus or minus 1 over 4. Once I've done those, I usually scratch out that one and move on to the next constant factor. So plus or minus 7 over 1, plus or minus 7 over 2, and plus or minus 7 over 4. Now normally I would just write 1 and 7 instead of 1 over 1 and 7 over 1, but I wanted to show you where that came from. So any of these are possible answers, but obviously not all of them are going to be answers. All right, for B, I'm going to kind of do this to the side a little bit because I kind of took up a little extra room. My constant is 10, so my factors are 1, 2, 5, and 10. Now, if you need to write those like we do with X factor, if you wanted to write 1 and 10, 2 and 5 until you didn't have any more, that's fine too. There's no need for them to be in numerical order. It's totally up to you. My leading coefficient is 2, so the only factors are 1 and 2. So my possible answers, I'm going to start off with my first leading coefficient, which is 1. So 1 over 1. Again, normally I would just write 1, but for the first couple I want to show you where the fraction is. And then I'm going to do plus or minus 1 over 2. And I'm going to cross that one out, move on to the next one. Plus or minus 2 over 1. And plus or minus 2 over 2. cross that out. Plus or minus 5 over 1, plus or minus 5 over 2, and plus or minus 10 over 1, and plus or minus 10 over 2. Now, as you start doing these more, you'll start to realize, okay, I've already got some of these answers. So if I were simplifying, this would be plus or minus 1, plus or minus 1/2, plus or minus 2. Well, 2 over 2 is 1, so that's a duplicate. I don't need to write that again. So then I'm going to move on. This is plus or minus 5, plus or minus 5 over 2, plus or minus 10. And then 10 over 2 is 5, which again, I already have. So I don't need to rewrite that one. So the more you do these, the more you'll start to recognize that pattern, and or like the duplicates, and you won't necessarily write those down. So these would be all of my possible answer choices. All right, for C, my constant is 4. So I've got factors 1, 2, and 4. My leading coefficient is 5. So my factors are 1 and 5. So my possible answers, plus or minus 1, plus or minus 1 over 5, plus or minus 2, plus or minus 2 over 5, plus or minus 4, plus or minus 4 over 5. And then one thing I want to point out with D, it does say 5x cubed minus 12, but we are really only looking at the whole number part of this. So my constant is 12. So I'm looking for factors of 12. 1, 2, 3, 4, 6, and 12. I don't need to worry about that negative. So I'm going to write that. So ignore the negative. My leading coefficient is 5. So my factors are 1 and 5. So here we go with our possibilities. Plus or minus 1, plus or minus 1 over 5, plus or minus 2, plus or minus 2 over 5, plus or minus 3, plus or minus 3 over 5, plus or minus 4, plus or minus 4 over 5, plus or minus 6, plus or minus 6 over 5, plus or minus 12, and plus or minus 12 over 5 would be all of my possible answers. All right, so now we're going to take those possible answers and what we know using synthetic division. We're going to find some answers, find some zeros. So here we've got x cubed minus 5x squared plus 4x plus 4. I'm going to start off with my constant, which is 4. Those factors are 1, 2, and 4. My leading coefficient in this case is 1. That's my favorite, because when the denominator is 1, my possible factors are really easy. It's plus or minus my constants, 1, plus or minus 2, plus or minus 4. So I usually like to just start with 1, just to see what's going to happen. So I'm going to start off with 1 in my synthetic division. My coefficients are 1, -5, 4, and 4. So let's see. Now, in order for this to be a 0, my remainder is going to need to be 0. So bring down the 1. Multiply. 1 times 1 gives me 1. Add. -5 plus 1 is -4. Times 1 is negative 4. 4 plus negative 4 is 0. 0 times 1 is 0. 4 plus 0 is 4. So unfortunately, that is not going to be an answer. So we will try again. Then, so sometimes a lot of people like to go through all the positives. I personally like to do at least +1 and -1 before I move on to other numbers. So I would do -1 next. So my coefficients are the same, 1, -5, 4, and 4. That looks too close. Whoops. So bring down the 1. 1 times -1 is -1. Plus -5 is -6. Times -1 is +6. Plus 4 is +10. Times -1 is -10. Plus 4 gives me -6. So unfortunately, that answer doesn't work either. So from this point on, I usually would go through all the positives and then all the negatives. It's just personal preference. So I'm going to go to 2 next. Got 1, -5, 4, and 4. Bring down the 1. 1 times 2 is 2. -5 plus 2 is -3. Times 2 gives me -6. 4 plus -6 is -2. -2 times 2 is -4. And 4 plus -4 is 0. So this is a solution. So I'm going to go ahead and write x equals 2 at the top because I'm going to keep a running list of all of my solutions. Now I've got this polynomial x squared minus 3x, minus 2. Now I could see if that could factor. This one in fact does not. It kind of looks like it would, but it doesn't. If it was +2, then yes it would, but with -2, there's no way for us to add a positive and a negative number that multiply to make -2 and add to make -3. So I'm going to have to use our good old handy dandy quadratic formula. Luckily, I've already got my A, B, and C values from the synthetic division that I did. So I'm going to use those values. So quadratic formula, -b plus or minus the square root of b squared minus 4ac all over 2a. Now I'm going to start cleaning it up. Negative times a negative is positive. -3 squared is 9. -4 times 1 times -2 is 8. And then 2 times 1 is 2. And lastly, I'm just going to clean up my radical. That becomes radical 17. So 3 plus or minus the square root of 17 all over 2 becomes my second solution. So I'm going to write that back at the top. 3 plus or minus the square root of 17 all over 2. All right. Let's see. Oh, I wrote way too big for that. All right, for B, I have a greatest common factor. Just going to kind of separate that. I've got a greatest common factor of x because I don't currently have a constant term, and I need a constant term. So I'm going to go ahead and take x out. That leaves me with 2x cubed minus 7x squared minus 7x plus 12. So now I have a constant term. So my constant is 12, so my factors 1, 2, 3, 4, 6, and 12. Leading coefficient is 2, so my factors are 1 and 2. My possibilities, plus or minus 1, 1/2, 2. 2 halves is just 1, so don't have to write that again. 3, 3 halves. 4, 4 halves is 2, so I don't have to write that again. 6, 6 halves is 3, so I don't have to write that again. 12, and then 12 halves is 6, so I don't have to write that again. So these are my possible answers. Now I am going to move this over so that I'll have room to write. So I'm going to come over here. So I always start off with 1. My coefficients are 2, -7, -7, 12. So bring down the 2. 2 times 1 is 2. Plus -7 gives me -5. Times 1 is -5. Plus -7 gives me -12. Times 1 is -12. Plus 12 gives me 0. So I have found one x value. Now this is 2x squared minus 5x minus 12. So we can do a couple of different things. We can go ahead and do quadratic formula, or we can, try to factor. This one does factor using bottoms up, so it's totally up to you how you want to do it. If you want to do quadratic formula, go for it. If you want to try to factor, go for it. So 2 times -12 gives me -24. B is -5. Factors of 24 are 1 and 24, 2 and 12, 3 and 8, 4 and 6. I need one of them to be negative because my A times C is negative, so I'm going to look at B. B is negative, so I know that my bigger values are going to be negative. And if I add those together, the ones that add up to be -5 are 3 and -8. But we multiplied by A, so I need to divide that back out. I'm going to simplify if I can. The 3 halves doesn't simplify, but -8 over 2 becomes -4. So I've got x plus 3 halves and x minus 4. Now this is again a situation where you could rewrite that first factor, but since we're setting them equal to 0 anyways, I would just leave it as is. It's going to save you a couple of steps. So this becomes x equals -3 halves and x equals 4. So kind of going back to the beginning, I've got x equals 1, x equals -3 halves, and x equals 4. But remember, my fundamental theorem of algebra told me that whatever this exponent is how many solutions I have to have. So going all the way back to the beginning, I took that x out first as my greatest common factor. I still need to set that equal to 0. So x equals 0 is another of my solutions. So all of my solutions are x equals 0, 1, -3 halves, and 4. So for C, I forgot to change this. I forget every single year. I don't know why. I need to just figure it out and get it done. But I forgot to change the problem. Those numbers are massive, and I don't want to deal with them. So we're going to make it a much simpler problem. So x to the fourth minus 5x to the third. And then we're going to say plus 5x squared plus 5x minus 6. That's going to be our problem. So starting off, this is my constant. Remember, we don't need to worry about the negative. We're just going to deal with the 6. So my factors are 1, 2, 3, and 6. My leading coefficient is 1, which is my favorite because that means my possible answers are just plus or minus 1, 2, 3, and 6. So I'm going to start with 1 and use my coefficients: 1, negative 5, positive 5, positive 5, and negative 6. So I bring down the 1. 1 times 1 is 1, plus negative 5 is negative 4, times 1 is negative 4, plus 5 is positive 1, times 1 is 1, plus 5 is 6, times 1 is 6, plus negative 6 is 0. So x equals 1 is definitely one of my solutions. So I'm going to write that, and I'm just going to leave it there for now. I'll come back and write them at the end. Now at this point, I still have 4 numbers here, which means I've got an x cubed, an x squared, an x, and a minus 6. I could try to factor this, but I can definitely at least use synthetic division. Now we can get duplicate answers, so I'm going to go ahead and try 1 again, but I'm going to use my new coefficients here. 1, negative 4, 1, and 6. Bring down the 1. 1 times 1 is 1, plus negative 4 is negative 3, times 1 is negative 3, plus 1 is negative 2, times 1 is negative 2, plus 6 gives me 4. So unfortunately, 1 is not a duplicate answer. So now I am going to try negative 1. So my coefficients are 1, negative 4, 1, and 6. Bring down the 1. 1 times negative 1 is negative 1. Plus negative 4 is negative 5. Times negative 1 is positive 5. Plus 1 is 6. Times negative 1 is negative 6. Plus 6 is 0. So this is a solution. Now I have x squared minus 5x plus 6. This I can factor into x minus 2 times x minus 3 and set each of those equal to 0. So I get x equals 2 and x equals 3. So when I write all of my zeros, I have x equals 1, negative 1, 2, and 3. One way to help you out is to use a graphing calculator, or you can use Desmos. So if you have the equation, you can actually, we're going to kind of skip down here, you can use these steps to help you graph the equation and then determine the zeros. You can use this on Desmos as well. Same thing, you're going to plug in the equation and find zeros on the graph. And those zeros are where it touches the x-axis. Now, if you're given a graph and you're trying to determine the zeros, then again, we are looking for where is it going to touch the x-axis? Where does it cross? So I can see it crosses here, here, and here. So my zeros should be -2, +4, and +6. Now we'll learn a little bit more about this in the next unit, but for this one, I've got here, 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 and here. When it turns around like that, like here, it turns around, that means it's got a multiplicity. It means the answer occurs twice. So my zeros are -2, 0, 1, and 3. But if you saw the equation of this graph, it would have some kind of x to the 6th, which means that there should be 6 solutions. And that's because my -2 and my 3 happen twice because it turns around.